Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
So, momentum. Previous problems in this playlist that I certainly recommend you read first before watching this, they were related to the change in momentum, right? So if we have a body, mass m, it has velocity v, and this thing mv equal p is momentum, and if there is no force it will continue to move, but if there is some force applied to this body, then during time t it will change delta p. And basically this is nothing else but another form of second law of Newton. Because of course if we divide delta 2, we send this from here to this denominator, or simply divide into delta 2, divide this into delta 2, divide this into delta 2, we will have delta p over delta t equal f, but delta p is the same like m delta v, because over delta t equal f. This what was before. That's what we discussed before. The change, I will remove this division because it's kind of obvious. The change in momentum equals the impulse of the force. We can say that it is exactly, and we acted like this, we can say that it's exactly like this, but actually it's not entirely true, because when we take mass out of here, because when we write delta p, it means p final minus p initial, and this equals mv final minus mv initial, and this equals mass factored out. It is v final minus v initial, and this is m delta v. When we do this, we assume silently that mass is the same in the beginning and in the end, and then it's exactly the same like second law of motion. But there is a little bit more to this. There are situations when mass can change, like for example jet engine, recoil, all kind of things. And another thing, that there are collisions. So there are two things where impulse and momentum comes very handy, and those are the cases when there are no external forces. So this is actually the case of external force, but there is maybe a situation when there are two parts of a body communicate with each other with the same force F, and this force F is the same because it's third law of Newton. And then we can say this for the first, it would be delta P1 equal F during the same time delta T, and here delta P2 would be the same force for F, opposite direction of course, delta T, right? And let's put it in the vector form. This will take into account direction, and then we will see F delta T are the same. And we can say that delta P1 plus delta P2 equals 0. Why it's the sum equals 0? Because actually, if I write it even in vector form, I should include here minus F delta t. So this force is this, and this force, this is F1 equal F, but F2 equals minus F, right? And those forces are the same, but they are opposite. F1 is the force that acts on this body, F2 is the force that acts on this body. And they are opposite in direction, so this is this. So if I add both, I add this to this, I will receive this because this will cancel out. So if this system as a whole consists of several bodies and they interact between each other and there are no external forces, there is the law of conservation of momentum. It means you can say that delta P of the whole system equals 0, or you can, so no changes, right? Or you can say the same like T equal constant. Momentum does not change. And that's all. And this is the result of interaction between two forces. And if we got it, if we assume this and if we understand this, let's solve a couple problems on collisions, and then we will solve problems when something is divided in two, in three, in many shards, and this is jet, principle of jet and center mass. But for the time being, let's start as always with a simple problem. We have mass and another ball, another mass points we can say, and this is staying and this traveling with V, and we have completely inelastic collision. So what we have, we can write it in the vector form, but because it all goes on this axis, one-dimensional, we say x, and we can say that initial momentum initial equal m multiplied by v, and this m multiplied by 0, so we can say plus m multiplied by 0. That's what happens. And then final, when it is final, it is completely inelastic thing, then this thing becomes 2m. Because this is two pieces of clay, no elasticity, boom. And this is one mass that travels with a speed, I don't know, v final. And p final would be two masses, because this is the total mass, multiplied by v final. And we can say that those equal each other because momentum in the beginning equal momentum in the end. And we will have mv, p initial goes here, p final goes to mv final. And that's it. And again, all that means that initial momentum equals final momentum. Initial momentum consists only of this body moving. This is staying, so mv. Final, they move together with some final speed. M as m goes away. V divided over 2 equals v final. And if I put v final first, I will have v final, v over 2. So they move together. And with the speed that equals half of the speed of first body. So you see how much I was talking about momentum, changes, that is the same form of second law of motion. Then when there is a system of two bodies interacting with each other, as long as they interacting only with each other, I can say that this is constant. But see how fast I solve the problem. I say, in the beginning, momentum is this, in the end, momentum is this, they are the same, final equal v over 2. I wasn't concerned at all. What was the force? How was it in the beginning of the collision? How was it in the end? Because obviously there is no force while the first body approaches. And then the force little more, then they tie together, force disappears. I wasn't concerned with all of this, how it depends on time, everything. All I say is this, very powerful, the law of conservations are very, very powerful. So the moment I understand how it comes takes a little bit of effort. But as long as I know that it is, the solution becomes extremely simple. I hope you liked, and the next problem would be full elasticity, head-on collision. So don't miss, like, subscribe, bell, question, problem. See you next time. Thank you.